Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to talk to you about sequences and series. Now the question that I've chosen to go through here is 2017 Paper 1 Question 7. In this question, in the first part of it, you're given the first three patterns of a sequence and you're asked to draw pattern 4. You should notice that across the top on the first pattern there's three boxes. Across the top on the next one there's 4, on the next one there's 5, so in the fourth one there should be 6 boxes along the top. And if you follow the same logic, the first one going down, or the legs of it, there's 2 in the first pattern, then 3, then 4, and in the fourth pattern there's going to be 1, 2, 3, 4, 5 boxes. So just make sure that you had something similar to mine. Obviously in the Leaving Cert, if you're doing this, it should be more accurate than the one I've drawn, and you should be using a ruler. Okay, so part B here gives you a table, and it asks you, it says based on the pattern shown, they want you to fill in the table. They want you to fill in the number of tiles in the first, second, third, fourth, and fifth pattern. You already have the first 4 patterns drawn out, so you can tell that the first pattern has 5 tiles. The second pattern is 8 tiles, the third one has 11 tiles, the fourth one has 14 tiles, and we need to deduce what the pattern is in order to figure out how many tiles will be in the fifth pattern. In order to get from 5 to 8, I must have added 3 tiles. To get from 8 to 11, I must have added 3 tiles again. If you add 3 tiles again, you get to 14. So obviously that means I'd add 3 tiles again. 14 plus 3 is 17. So the fifth pattern must contain 17 tiles. Okay, in C part 1, we're told to assume that the pattern continues. And we're told that the formula for the nth pattern can be given as Tn equals Pn plus Q. Find the value of P and find the value of Q. In other words, it means basically get the general formula for the pattern. Now you should realize that, as we noticed in part B, that this is a linear, or this is an arithmetic sequence. An arithmetic sequence is one that has a common difference. And in this case, our sequence clearly has a common difference of 3. With each pattern, I add 3 tiles to it. The first one was 5, the next one was 8, the next one was 11. There's a formula on page 22 in your maths tables that allows you to find the general formula for an arithmetic pattern. The formula for an arithmetic pattern is Tn equals A plus n minus 1 times D. Where A is the first term, in this case clearly my first term was 5. The first pattern has 5 tiles. And D stands for the common difference. In this case our common difference is 3. Because clearly we can tell from our table in part B that it's increasing by 3 tiles every time. So all I did on the next line was, instead of A I subbed in a 5, instead of D I subbed in a 3. Now you've n minus 1 times 3 here. Sometimes that confuses students, so I think it's easier if you just rearrange it. Rather than saying n minus 1 times 3, that's the same as 3 times n minus 1. That's just the format you're more used to seeing this. Because now we can just multiply it out. 3 by n gives me 3n, plus 3 by minus 1 gives me minus 3. To get the general formula then, you just need to add your like terms. 5 minus 3 gives you plus 2. So the general formula, Tn, is equal to 3n plus 2. So this formula allows me to figure out how many tiles are in like the 20th pattern, or how many tiles are in the 50th pattern, or any pattern they ask me for. Remember, they didn't actually ask you to write that, they asked you to find P and to find Q. So your final answer, you should say P equals 3, Q equals 2. Because P was the number in front of n, and Q is the number at the end. Okay, in C part 2, they've asked me to find the number of tiles in the 20th pattern. So you should realize that with the formula from C part 1 will allow me to work this out. I know that Tn is equal to 3n plus 2, where n is the pattern number and Tn is the number of tiles. So if they tell me that the pattern number is 20, I can work out what T20 is. Or in other words, how many tiles are in the 20th pattern. In order to do that, we just need to sub in. Instead of an n, we sub in a 20. We get 3 times 20 plus 2. 3 by 20 is 60, and then 60 plus 2 gives me 62. So your final answer for that is that T20, or the number of tiles in the 20th pattern, is just 62. In C part 3, it asks me to figure out which pattern has exactly 290 tiles. Remember, so we can use our formula Tn equals 3n plus 2, where Tn is the number of tiles and n is the pattern number. So if they tell me that I'm looking for the pattern that has 290 tiles, that means I'm subbing in Tn equals 290 and I'm trying to find the value of n. So when I did that, I end up with 290 is equal to 3n plus 2. In order to get n on its own here, I just need to subtract 2 from both sides. I get 290 minus 2 equals 3n. 290 minus 2 is 288. And in order to isolate your n, you need to divide both sides by 3, which means you end up with n is equal to 288 over 3. If you divide that in, n works out as 96. In other words, the 96th pattern will have 290 tiles. So your final answer here is this. In D part 1, we're asked to show that Sn equals 3n plus 3n squared plus 7n over 2 is a formula to describe the number of tiles needed to build the first n patterns. It's important you understand the difference between Sn and the formula Tn that we were using in part C. In part C, if you got T10, that tells you how many tiles are in the 10th pattern. And only the number of tiles in the 10th pattern. But if you get Sn, S10 refers to the number of tiles needed to build the first one, second one, third one, fourth one, fifth one, the whole way up to the 10th one. So it's the sum, it's all the first 10 patterns added together. So Sn is when you add up the first n patterns together. So we use a slightly different formula. Again, you should remember that we're dealing with an arithmetic sequence. We know it's an arithmetic sequence because it has a common difference. And if it has a common difference, we can just go straight to our maths tables and use our formula. The formula for Sn of an arithmetic sequence can be found on page 22. It's Sn is equal to n over 2 multiplied by 2a plus n minus 1 times d. And notice I have brackets, it's d times the n minus 1 and then square brackets around it because you're multiplying n over 2 by the whole thing. Remember that a represents the first term, which in this case is 5. D represents the common ratio, which in this case, the common difference, which in this case is 3. So all I did on the next line was instead of a, I subbed in a 5. Instead of d, I subbed in a 3. And then 2 multiplied by 5 gives me 10. 3 by n is 3n. 3 by minus 1 is minus 3. We can then just simplify what's in the brackets. 10 minus 3 gives me 7. And then I've got a plus 3n. Now I want you to notice here that I have Sn equals n over 2 multiplied by 7 plus 3n. All I've done is rearrange that. That is the same as n times 7 plus 3n all over 2. So rather than just having the 2 under the n, I have the 2 under the whole lot in the next line. And then you can just multiply n by 7 is 7n, n by 3n is 3n squared. And that's what we were asked to prove so that we know that we're on the right track. That's the formula that will allow me to work out the sum of the first n patterns. Okay, so D part 2 then asks me to work out the number of tiles needed to build the first 30 patterns. So you need to realize in order to do that, we need to use our formula for Sn, except in this case my n is going to be equal to 30. If you just sub in, that means that S30 is equal to 7 times 30 plus 3 times 30 squared all over 2. 7 by 30 is 210, 30 squared is 900. And if you then multiply 3 by 900, you get 2,700. Add the top line together and it works out as 2,910 divided by 2. So your final answer, the first 30 patterns all added together have 1,455 tiles. So I hope this video makes sense. If there's anything you're unsure of there or you'd like me to clarify it, just send me an email or let me know in class and I'll explain it differently.